Welcome back. This is Mr. Hassan's Maths channel. I'm now answering question number 2 from the June 2022 Cambridge IGCSE 0580 paper 4 variant 2. This question here is about angles in circles. So 2-part A, we've got this circle. We're told that the points P, Q, R, and S lie on a circle with diameter PR. So these are all on the circumference of the circle. And the important thing here that's going to help us in this question is that the diameter is PR. This is the diameter of the circle. It splits the circle into 2 equal halves. So work out the angle, the size of the angle PSQ, giving a geometrical reason for each step of your working. So we're asking to find the angle PSQ. Angle PSQ is this angle over here. It's always the letter in the middle is where the angle is, and these 2 letters on either side where the arms come from. So this is angle PSQ. That's what we have to find. This is what we are focused on finding the size of. Now, we got to find this angle. Now, how can I relate this angle to the other angles? Well, I know that PSQ, if I follow where it comes from, follow where PSQ comes from. PSQ comes from the points P and Q. Okay, so it's standing on PQ. So we got to think about another angle which actually stands on the same 2 points. Okay, so if we follow lines leaving P and Q, so for example, if I just draw a diagram here to illustrate, make this a bit thinner. Okay, so we can see that this is PSQ. Another angle that starts at P and ends at Q, so standing on PQ, would be the angle PRQ. Now PRQ and PSQ, they both stand on the same arc. They're both standing on the same arc, okay, which is PQ. So we can see that PRQ and PSQ are going to be the same. Now, for me to find PRQ, what I can do is I have to think about other angles. Now, as I mentioned, the diameter is PR. So one of the things that we should know from our understanding of angles in circles is that angles standing on the diameter are 90 degrees. So the angle PQR must be 90 degrees. So this angle here must be 90 degrees. Okay, so I know that this angle is the same as that angle. Let me call this angle X. This angle is also X. Right? They're the same. And this angle is 90 degrees. Now I've got this triangle PRQ, which I can use. I have 2 angles in the triangle. I know this is 90, this is 29. I can find what X is. So if I want to show my steps in a very logical way here, which is what they require, what I can do first is I can say, first of all, I can say angle PQR, this angle PQR, I can write it like this, is equal to 90 degrees. And you can say angles in a semicircle. Angles in a semicircle. Okay, that's what they're looking for, the word semicircle. Angle standing on the diameter. That's how you would phrase it normally. All right, so that's 90 degrees. And we can say that angle PRQ is equal to angle PSQ. PRQ, first of all, is equal to, we can use the fact that these 3 angles add up to 180 degrees, is equal to 180 minus the sum of 90 degrees plus 90 degrees. And this is because they are angles in a triangle. Angles in the triangle, the sum of angles in the triangle is 180 degrees. So we can work out what that is. In fact, I should have written down the value of that first. Okay, let me do that first. So that's equal to 180 minus, that's going to be 119, which is going to be 61 degrees. 61 degrees. You can say angles in a triangle that add up to 180 degrees. So therefore we can say PSQ is equal to PRQ, which is equal to 61 degrees. Why? Because they are angles standing on the same arc, or you can say angles in the same segment. Angles in the same segment. That's how you can, the angle standing on the same arc in the same segment. That's how you normally would state that. And those are the three statements you need to get the marks of this question with the reasons. Okay, so this angle is 90. These two angles add up to, with this two as 180, so this is 61. We can confirm that. 180 minus 90 plus 29. That's right, 61. You can make sure. Well, in this up to June or November 2023, yes. When it comes to November, February, March 2024, some of these type of questions might be in the non-calculator paper. So you have to brush up with your mental arithmetic. Okay, so there's the answer to question 2A. Now for 2B, which was a question that was actually asked. Now it says the points A, B, and T lie on a circle, and CTS is a tangent to the circle. This is the tangent to the circle. So it touches the circle at T, it doesn't pass through it. And angle ATS is 98 degrees. Okay, and the straight lines, and AB is equal to BT. So they have an isosceles triangle. So from this, let's mark down some of the things that we can straight away, say. I know, for example, that this angle is the same as this angle. Why? Because it's isosceles. Right. The other thing I know, and this something which we should know, is called the alternate segment theorem. When you have a tangent meeting a chord, as we see here, then the angle formed on the other side of the chord, okay, this angle over here, is going to be equal to the angle between the tangent and the chord, the opposite side. So this angle must be 98 degrees. And that's the key to answering this question. Once we know this angle is 98 degrees, we can find, for example, this angle, these angles. We can find all these other angles now because this is an isosceles triangle. If this is an isosceles triangle, I can find what these two angles are. I can say the angle, for example, I can say angle BAT is equal to the angle BTA, which is 180 minus 98 divided by 2. Okay, 180 minus 98 divided by 2, which is going to give you, that's going to be 82 over 2, which is 41 degrees. So this is 41 degrees, and this is 41 degrees. Now that helps us. Why? Because now I can work out, for example, I can work out what this angle is here. All right, if I know this angle, then I can use either this small triangle here or this big triangle to work out what C is. If I consider the big triangle, I can use, for example, this angle, the triangle ACT. Okay, if I consider that, then this angle plus the whole of the angle add up to 180 degrees. So how do I find this part of the angle? I can say that angle, I'm doing my work up here. It should be down there, but it's just so that we can see what's happening. All right, so I have to scroll up and down. I can say, for example, angle CTB, this angle over here, CTB, is going to be, because this is a straight line, CS, these three angles are on a straight line. It's equal to 180 minus 98 plus 41. So it's 180 minus, that's going to be 139, which is 41 degrees. So this is also 41 degrees. Okay, so the total angle here is going to be 82 degrees. So I can now say the angle that we're trying to find, which is angle ACT. Okay, I can say ACT, therefore, is going to be 180 minus, and I'm going to have 82 plus 41. 180 minus 82 plus 41. Okay, because I have this angle plus that angle make a triangle. So that's 180 minus, that's going to be 80 plus 40, that's 120, that's 123. So 180 minus 123 is 57 degrees. So 57 degrees is ACT. Okay, so I've shown the steps up here mostly, and that's fine. We could have also found what this angle is here. We could have done 180 minus 98, which would have been 82. And then we could have said, the angle here is going to be 180 minus, again, 82 plus 41. So it will be the same answer. So whichever way you do it, you end up with your same answer. Angle ACT is 57 degrees. So there's the answer to this question. Now, the key to this question is understanding the alternate segment theorem. When a tangent meets the chord, okay, the angle formed between them is equal to the angle standing or subtended by that chord on the opposite side of the circle. So this angle here is the same as the angle there. These two are both 98. That's the key to answering this question. Once you've got that angle, all the other angles fall into place. Okay, so that's a very important rule that you need to know. Okay, so you should know the alternate segment theorem for us to be able to answer this question properly. So that concludes this question from this June 2022 paper of paper 4, variant 2 from the Cambridge syllabus 0580. Other questions from this particular paper can be found in the playlist that will appear in this section over here. Other questions from the topic of angles in circles can be found in the playlist over here. You can subscribe to my channel by clicking on this link, and you can click on the link over here, which takes you to a video which will explain how to use my channel in an efficient manner. Thank you for watching, and see you soon.